The risk of water hammer applies to all pipelines. Water hammer can have various causes and may entail drastic consequences. KSB can help you determine the preventive measures to reduce water hammer. Taking this pumping system as an example, comprising a pump, a swing check valve, the piping with its on-site layout and a reservoir, the water hammer effects of a pump failure with and without countermeasures will be analysed and illustrated. In this diagram, the green line represents the elevation profile of the pipeline. The absolute pressure is shown as pressure head curve. During normal operation of the pump, this curve falls slightly over the entire pipeline profile. The red lines are the envelope curves and represent the maximum and minimum pressures occurring over the entire period. In most cases, pump failure, for example when the pump is switched off or a power failure occurs, is the most critical system condition with regard to water hammer. A sudden pump failure will cause the pressure head of the pump to drop sharply. This low pressure wave will then travel through the entire pipeline at wave propagation speed. At the free outlet into the reservoir, the negative pressure wave is reflected back towards the pump. The swing check valve is now closed. The low pressure wave is reflected as a higher pressure wave. Water hammer can damage pipelines both through positive pressure peaks and negative pressure. Whenever the pressure head curve is below the geodetic head of the pipeline, negative pressure is present. In this example, the highest negative pressure occurs at the high point in the middle of the pipeline section. The permissible negative pressure pipelines and all components, such as valves and sealing elements, can cope with is limited. In order to compensate the drastic pressure head fluctuations that may occur, KSB offers consultation and the selection of various preventive measures. In this example, one air valve is installed in the pump station and two further air valves in the course of the pipeline. In the case of negative pressure, the air valve opens, allowing air to flow into the pipeline. This reduces the negative pressure. The positive and negative pressure waves of the pressure head curve are reflected at the air valves throughout the entire pipeline. As can be seen from the pressure head curve over time, in this example the positive and negative pressure waves run back and forth between the valves. Their influences are locally limited. The pressure head curve is adjusted to the local geodetic altitude of the piping by the valves. This means the pipeline pressure is close to the atmospheric pressure. The use of air valves can significantly reduce negative pressure in particular. An air vessel is installed downstream of the swing check valve. In the event of a pump failure, the pressure head curve collapses much slower with this preventive measure. Air vessels are filled with water and gas. Unlike water, gas is compressible. As long as the system is in operation, the gas is compressed by the pump pressure. If the pump fails, the pressure drops and the gas can expand. Then the air vessel feeds water into the piping and compensates the lack of flow rate of the pump. When a positive pressure wave approaches the air vessel, water is forced into the air vessel and the gas is compressed. This reduces the positive pressure. With its compensating effect, the air vessel ensures much smoother pressure changes. In contrast to air valves, this is a closed system. No dirt can be drawn into the piping at negative pressure. Air vessels can significantly reduce positive pressure peaks and negative pressure in the piping system. Some pumps, for example the Savertech, can be designed with flywheels. This increases the mass moment of inertia of the pump. If the pump fails, the pump speed drops slower. The pump keeps pumping water into the discharge pipe for a longer period of time. As a result, the first negative pressure wave can be significantly reduced. Flywheels do not require any additional maintenance and are extremely reliable in operation. The longer the pipeline, the larger the flywheel would have to be. In the case of very long pipelines, the technically feasible dimensions of the flywheel are limited. Hazardous piping damage caused by water hammer can be prevented by using the measures described. KSB would be pleased to support you in selecting your individual solution.